So thank you once again, everyone, for joining us at EarthEngine at SG. Today, we're really excited to have Dr. Keiko Nomura, who is the Director of Product Development at ClimateEngine. And Keiko is one of the early adopters of EarthEngine, having used it extensively for her PhD research. Previously, she worked for Space Intelligence in Scotland, as well as the UNDP and UNEP on REDD+, which means reducing emissions from deforestation and forest degradation in developing countries, and mainly based on work in Southeast Asia. So driven by the urgent need for better data, Keiko left the UN and then spent 3 years in research. And she developed methodologies to detect forest loss and identify drivers of deforestation with high accuracy and at low cost. So we're really excited to have her here today to share with us some great EarthEngine tips and tricks. And these are also linked to her great science communication work on Twitter. So I encourage you all to also follow Keiko on Twitter and look out for the great posts that she has. So I'm going to stop sharing my screen now and allow Keiko to start the presentation. Thank you, Keiko.
Thank you so much for the introduction, Sabrina. I also just realized I didn't include my Twitter handle in the presentation, which is quite a surprise, but I kind of assumed most of the people here probably know my Twitter handle, which is KEIKO_GEO. So if you are interested, please check or follow me on Twitter. So as I was introduced, my name is Keiko. I'm currently the Director of Product Development at ClimateEngine. I was previously based in the UK, and my PhD is from the University of Edinburgh, where I developed these EarthEngine tips during my PhD years. So it started actually back in April 2019. I was kind of digging, when was this my EarthEngine tip #1? And actually, like looking back, it's one of the most important tips, I believe, that I have shared so far was the tip #1. But as you can see, unlike my recent tips, there's no GIF, there's no video, there's no visual, just a few sentences, which I thought appropriate for Twitter. But I got, what, 6 likes and 1 retweet. So it wasn't a big noise at all. But then by October 2019, this is still the most likes I got from the tips. This was about NDVI. And then following year, February, I collaborated with Google to write a blog about these tips. So that's how it started. And now I consolidate my tips on my homepage, which I put the URL there. I put as much as possible, good ones and some important ones that I think that they are important. So yeah, there are also other tips available too. And there are very good documentations from Google EarthEngine today, unlike a long time ago where there weren't a lot of tutorials available when I started EarthEngine. So whenever I found out how to do things, I felt the urge to share with the world. But now there are so many tutorials available. And also, if you are already a user, I recommend that you contribute to the community tutorial. Those are great resources for researchers. Now, because there are so many great tips available today, I'm just gonna put this one website on GitHub, curated by Andrea Nallister. about these are the basically links related to Earth observation code, and they have a whole section on EarthEngine. So I recommend checking that one as well. Now, if you attended my previous talk, I mentioned a little bit about not to use loop on EarthEngine, but try to use map instead. So I want to go a little bit deeper on this. And I also heard the participants for this session are more advanced. So I try to tailor toward that direction. So in this example, I wanted to run classification 1,000 times using different training samples. And if you were to use the loop function, which is not really recommended to use on the EarthEngine, this is how it will look like. If you are a Python user, you immediately see the familiarity. You will create the empty list first and then specify where it starts and where it ends. And then that's it. This will not run 1,000 times for sure. It will not run. It will try to run on the client side, and it's just not a good practice. So you want to run this on the server side. What that means on EarthEngine is you will use a map function, and for the list of number of times you want to run this, you will set it as list sequence in this case. So it's going to start with random seed 0 to 1,000. And then you wrap it as a list and you export to your Google Drive. So that's how you can get 1,000 runs of accuracy without any timeout. Now, other example is you may want to run random forest classification, for example, with a different number of decision trees. You want to see which one is the optimal number of decision trees, or would there be any difference if it goes over a certain number? So in this case, let's say you wanted to try decision trees 100, 200, and 300. Just like how we did previously, you will put this as a list and then map it in a function, and the number is n here. I don't know if you can see my cursor, but number of trees as n here. And if you print this whole variable, it will show overall accuracy of 100 using 100 decision trees, 200 and 300. So the next challenge may be you also want to change the minimum leaf population and see what happens. Minimum leaf population is very important to tweak, because if you don't set anything, the default is 1, and that will certainly overfit. Literature recommends 30, but you can test, 5, 10, 20, and 30. Now, if you try to do this with JavaScript on EarthEngine, it is a little tricky. It was certainly required some thinking, and basically I got a little bit creative here, that although map function only allows one algorithm, this is simply a list. So you can do basically 2 lists here and produce accuracy over this basically 3 times 3. So I'm trying minimum leaves 10, 20, 30 over decision trees 100, 200, 300. So 9 different cases, and these are the different overall accuracies based on these different parameters. So you may notice that as it gets more complicated, you may want to add more conditional sentences, then it gets a little more difficult perhaps. And actually it's easier in this case if you use Python, Jupyter Notebook. It's a little more intuitive too. You just say tree range. This is basically a list, 100, 200, 300, and you want to try minimum leaf 10, 20, 30. And you do need to create an empty list as an output because you want to know, in addition to testing scores, you want to see training scores so that you can see if you are overfitting or not, what would be the difference between training and testing scores and so forth. And the index range is to see what are the combinations are when you print it out. So as you can see, the first loop is for the leaf range. You are taking each leaf here in the list and then additional nested loop, you are adding decision trees, 100, 200, 300. And then simply list the functions and then print it with this index range. So I have 100 decision trees with 10 minimum leaf population. This is the overall accuracy, goes till 330. As you can see, as you increase the minimum leaf population, accuracy goes down. However, the difference between testing and training becomes smaller. So this is on the nested loop. And as I said, the more sort of sensitivity analysis you may want to do, Jupyter Notebook may be easier for you to go on. And I talked also about the feature importance function available from a classifier. So what that means is when you do classification, you want to know which features such as NDVI or B band, which one is more important than the others. In other words, if you take one of the indices you are throwing in your classification, how worse they will do as a result. So that kind of statistics are available if you use explain function. So what you want to do here is your classifier.explain, and then you create a feature to try to get the importance variable. And get info is a way to transfer data from EarthEngine to Python here. And then I imported pandas and matplotlib for visualization purposes, and then create a figure. And this is an example how it looks like. In this case, I used my previous research as an example, which was published in the one of the Nature journals. And most important variable or feature in this case is VV mean. So Sentinel-1 VV mean over 1 year. That turned out to be the most important feature in this particular classification exercise. And one other function I wanted to highlight, and it's already written by Justin Braden from Google, is that if you go to this community tutorial page and click time series visualization, and then there's this function, you may have to Control F and find this FC to dict dictionary. So this means feature collection to dictionary. So he already wrote a function where we can transfer data from feature collection to dictionary. And why this function is amazing is that basically you can put any feature collection from EarthEngine to this function and use get info, and then apply pandas and get all sorts of statistics or data in a more friendly way, that there wouldn't be lots of brackets and commas as you see in EarthEngine JavaScript. You will see in a table format, or it's going to be easy to to create these type of graphs and figures. So I highly recommend to try this FC2 dict function. It's very useful. So those are some little bit intermediate to advanced tips today, and I hope you liked it. I plan to continue to do the EarthEngine tips as much as possible. So please maybe follow me on Twitter. That would be the best way to see it. Thank you.